Okay, we had the problem, 50 kilogram mass with a kinetic energy of 1,000 joules, and we wanted to know its velocity. Now, the solution is very similar to what we did over here. The definition of kinetic energy, 1/2 mv squared is kinetic energy. Now, we're not using the same units. These were vague units. We didn't specify what these units are. We're now working with SI units, but that's the only difference between what we did here and what we're going to do here. Okay, to find the velocity, then, we take the square root of twice the kinetic energy divided by the mass. This we obtain just by solving this equation for V. And we should put a plus or minus in here. I had it here and here. I just didn't bother to write it down here. And I need to be careful about that, and so do you. Okay, so we plug in our numbers. 2 times 1,000 joules divided by 50 kilograms. The numbers come out easily. That's 2,000 divided by 50 is 40. It's joules over kilograms. Now, we keep the 40 static for about 4 steps here while we work out what joules over kilograms means, and this is the real import of this question. What's a joule? It's a unit of work. What's work? Force times displacement. What are the units of force? Newtons. What are the units of displacement? Meters. So a joule is a newton times a meter, because work is equal to force times displacement. Okay, now what's a newton? A newton is a force. And how do you get the unit newton? How do you get force? Well, if you recall, we multiply mass times acceleration, so the units of mass times the units of acceleration should give us the units of force. So a newton is a kilogram, unit of mass, multiplied by a meter per second squared, unit of acceleration. Multiplying all this out, we get a meter times a meter is a meter squared, divided by second squared. The kilogram divides the kilogram. We're just left with meters squared over seconds squared. And now we have the square root of 40 meters squared over seconds squared. Square root of 40 is 6.3, roughly. And the square root of meters squared over seconds squared is just meters over seconds. Why? Because if you square meters over seconds, you get meters over seconds times meters over seconds, which gives you meters squared over seconds squared. So we really need to understand the units. That wasn't an issue over here. We just said we got energy units, we got velocity units, we got distance units. Just trying to keep that complication out of our thinking for a minute till we get an idea of how energy might behave. But now we do this. I also have a no-no on the board, and this is not related to this, it's related to this. Some people will often want to do mass, average velocity, kinetic energy. And no, if you do 1/2 mv squared on the average velocity, you don't get the average kinetic energy. Velocity is not linear, so the average velocity is not linear related to the initial and final velocity, and that kind of averaging simply does not work.